Today is October 10, 2020. I did this theorem in high school about how 0 times infinity equals 1. So what happened was my dad told me, write down the theorem and mail it to yourself. And so that's what I did. That was in 1987. So I have the envelope right here that I mailed myself, if you can see that. April 1987. And so now I'm about to open it. Here we go.
Here we go. We're gonna open it. You can see it's sealed. Look, I put my initials here on the back. Okay, now we're gonna open this. Here, we're gonna open this. Da, 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 da. Man, the paper is like super thin.
Here it is.
Man, this is my handwriting from high school. Wow. Look at that. April 8th, 1987.
Turn it over. Alright, wait, move your hands.
Oh, look, real numbers, imaginary numbers.
Alright, can I stop recording?
Yeah.
Okay, I am going to explain this math theory on how we get to a number times 0 equals 1. This was done in April of 1987. I had mailed it to myself and I just opened up this letter. Okay, so here's how it works, right? So we have this circle, we have a radius of 1. We have 3 different sections. We start off by saying that the area of this triangle is less than or equal to the area of this section of the circle, which is less than or equal to this larger circle. Okay, so we know that any triangle, the area is the width times the height divided by 2, okay, or times half. So we know that the width here is, if the angle is theta, we have cosine theta, the height is sine theta. So the area is cosine theta times sine theta times 1/2. That's the area of this triangle. We know that to get the area of this section here is, the formula is r squared, which we know is 1, times theta times half. Okay, so if we have r squared when r is 1 is half of theta. Okay, so we know that this is half of theta to get this. Now for this larger triangle, we know that the height is tangent theta. The width, as we said, the radius is 1, so this width is 1. So we have 1 times tangent theta times 1/2, we get that area, which is represented in this equation right here, right? So this is the area of the smaller triangle, the area of the section of the circle. This is the area of the larger triangle, right? So we have small triangle is less than or equal to the section of the circle, which is less than or equal to the larger triangle. So now we're going to simplify this by simply multiplying by 2. So we then get cosine theta times sine theta is less than or equal to theta, which is less than or equal to the tangent of theta. Now what we're going to do is simplify this. We're going to divide by sine. We know that tangent equals sine over cosine. So if we divide everything by sine, we get cosine theta is less than or equal to theta over sine of theta is less than or equal to 1 over cosine. Now what we're going to do is we're going to take the inverse of this. We're going to multiply, we're going to inverse everything, right? So the cosine of theta is 1 over cosine theta. So here we flip this, sine over theta becomes theta, and multiply. So essentially we're taking all this to the power of -1. Okay, so we have cosine theta on this side. Now we're going to apply limits. So we have, as theta approaches 0, we have cosine theta. Now we know that the cosine of 0 is 1. So therefore we know that this is equal to 1. Similarly, on this side, we know that as theta approaches 0, the cosine of theta is of cosine of 0 is 1. So we have 1 on this side, and we have the side, and I'll get to this middle part in a moment. So we have 1 is less than or equal to this thing, which is less than or equal to 1, which only means that this thing can be equal to 1. This thing is the limit of sine over theta, sine theta over theta, okay? Which is what I have represented here. Now we're going to break this out, and we're going to simply say the sine of theta times 1 over theta, and we have the limits of all that, right? So, and all this equals 1. Okay, so we know that what is this, right? The limit of theta over 0. Oh, let's do the sine first. So the limit of, as theta approaches 0, sine of theta. So sine of 0 we know is 0. So 0 times this thing equals 1. Okay, so now this should be interesting because we've always been taught 0 times anything is 0. So we've proven that 0 times something equals 1. So I'm calling this thing S, okay? S is actually pretty straightforward. S is as x, what I was calling theta, now I'm calling x. As x approaches 0, 1 over x, this thing, mathematically we've proven times 0 equals 1, right? 0 times S equals 1. So now you could say, well, what is S? One could imply that, or infer that S is infinity. I'm not saying that. One could come to that conclusion, but what I am saying is 0 times that limit does equal 1. So some number times 0 equals 1.